So we want to discuss the concept of definite integration. And when we first started talking about integrals, we discussed the idea that we could take an infinite number of rectangles and stick them underneath the curve, and then we could find the area of those rectangles, and that would be the integral. So we defined it like you see on the screen, where the limit as n approaches infinity of sum from k equals 1 to n of k, x to the k, delta k. Delta k was our base, this was our height, and we just plugged in an infinite number of them. And we called that the definite integral, and I told you then that we would talk about how to do that in terms of the mathematical way of doing that a little bit after we figured out just some rules for integration. And so that's what we're going to do. And so what you have to understand about definite integration is that all the rules of integration apply: the power rule, the constant rule, sum and difference rule. But there's an added, an added step, because a and b are now there, and a and b are called the lower and upper limit of integration. And what we have to do is we have to figure out, okay, now that we've got the integral, what happens? So we can integrate using the same techniques that we use with indefinite integrals, but then what do we do afterwards? All right, and we're going to talk about that using what's called the fundamental theorem of calculus. Okay, I've highlighted fun. I think you'll see how fun it is in a minute. But basically what it says is that after you've integrated, then you just plug in the upper limit into your antiderivative, and you plug in your lower limit, and then you subtract the result. And that gives you the area. And it's important to understand that if f is continuous on AB, that's the important part. It has to be continuous. So just like with derivatives, you can't take a derivative that's not continuous, then same thing here. So this is the notation. We write it with this square bracket from a to b, and then we plug in b minus a, and then we actually work it out. And what we're going to do is we're going to get a number. It's actually going to give us a value. Okay, and just before we jump into some examples, I want you to understand a couple of things that are true of this. So because this is how this works, this is the way that the fundamental theorem of calculus works, there are some rules for definite integration. One is that if you're going from a to a, the area underneath a specific spot is always 0. It's infinitely small. If you're going from a to b, then that integral is going to be negative the integral from b to a. All right. And then thirdly, if you want to integrate something in between a and b, and for some reason it's not continuous, then you can take the integral from a to c, and then from c to b. And you might want to do this when, for example, the curve goes negative or something like that. So you're looking from, if you have a curve that's kind of going like this, and I want the area, let's say that's a and that's b, then we might want to integrate from a to c and then from c to b. All right, so there are times when you might want to use that. And then the final rules just say that if f is integrable, that is, you can integrate it from a to b, and f is positive, then the area is also positive. So the integral, the definite integral, is always positive. And if you're integrating f of x and you're integrating g of x, and the function f is bigger than the function g, that is, it's greater than in terms of the y values, then the integral also is greater. Okay, and then I just made a note that all the rules for indefinite integration also apply. Now, it's not necessarily that difficult to wrap our head around the fact that, for example, if the function's bigger, then the area underneath of it's going to be bigger. So these are fairly obvious statements, but they are important to understand. So we're going to just do a few examples of how to use this now that we kind of have an idea of the rules. So here's an example of a definite integral. So first off, we integrate. We integrate x, we get x squared over 2. Now generally what we've been doing is putting a plus c, but here we don't. We just put x squared over 2, and then we go from 1 to 3. And the reason we don't is that when you then plug in 1 and 3, you would have 3 squared over 2 plus c minus 1 squared over 2 plus c. So the c's would cancel. So we don't need a constant in there because the constant will just, because of the nature of the fundamental theorem of calculus, it will just subtract out every time. So we don't put the c in. We just plug in to our antiderivative 3 and then 1. So 3 squared is 9, 1 squared is 1, so we get 8 over 2, which is 4. And our answer then with these always comes out to a number. Okay? Now, what's interesting is about these ones is that because you have an actual numerical answer, it's not algebraic in nature, your calculator will solve them for you. So if you have an antiderivative and you want to check, you need to show your work, but if you want to show a check, you can use your calculator to do that. So here's another example. So first off, we're going x squared minus 3x dx, and we're going from 3 to 7. So we're going to integrate first. So the integral of x squared is x cubed over 3. The integral of minus 3x is minus 3x squared over 2. And then we write from 3 to 7. We plug in 7, and when we're plugging in 7, we plug it into all the x values. So we get 7 cubed over 3 minus 3 times 7 squared over 2. That's with 7 plugged in, then we go minus, and then we plug 3 in. So we get 3 cubed over 3 minus 3 times 3 squared over 2. And then from here, it's just a matter of working out what our answer is. So we go, okay, 7 cubed is 343. 3 times 49 is 147. 3 cubed over 3 is 3 squared, which is 9. And 3 cubed over 2 is 27 over 2. And then we try to get a reduced fraction. So we get a common denominator, put everything over 6. And we end up with 272 over 6, which reduces down to 136 over 3. And that's without a calculator. Now, if we want to use the calculator, what you do is you just go to your menu. Okay, well, actually, first go to your scratch pad, I guess, because you have to have it. But then go to calculus, and you want a numerical integral. Okay, and it's going to actually show you the format like we have here. So we're going to go from 3 to 7. So we go 3, 7, and then in there we're going to put our integrand. So it's x squared minus 3x. So we're going to go x squared minus 3x, and then we want it to do with respect to x. So we're going to put dx. So you write in exactly what's there, and it will tell you it's 45.333333. Now, if we want to figure out what that is, oops. We can go to, it's a fraction, we can go to menu and then go to number and approximate it to a fraction. And it gives us 136 over 3. Okay, this is using a TI Inspire, which you guys all have, but if somebody's watching the video that doesn't have one, you can do this on a TI 83 and an 84 as well. And I'm sure there are other calculators that will do it for you. So that's how you use your calculator to find these indefinite integrals. So the concept is pretty easy to do. It's just remembering what you're doing in terms of, are you indefinite integral, then you got to put a plus c. If you're definite integral, then you don't. You have to plug the numbers in and see what you get. So here's another example. I have cosine x, so I integrate that, I get sine x, and then it's sine x from 0 to pi over 2. So I plug in pi over 2, and I plug in 0. When I plug in pi over 2, I get the sine of pi over 2, which is 1, and when I plug in 0, I get sine of 0, which is 0. So my answer comes out to 1. And again, on your calculator, you can check that. All you have to do is make sure you're in radians, okay? And then once you've made sure of that, go to your calculus numerical integral, type in 0, and you can actually type in on this calculator, you can put in a fraction and go from pi over 2, okay? And then you can go in here, go to trig, cosine of x, and it's dx, and we hit enter, and it gives us 1. So you can always check your answer as long as you have a calculator. to see if you've done it correctly. But that is the concept of definite integration, and it's pretty simple, pretty straightforward in terms of the extra work. You have to integrate still, and we'll be doing that for the rest of what we're doing with integrals. We'll always have to do the integral rules, so we'll have to integrate sine or cosine or whatever. But when you've done it with definite integration, you just have to take the boundaries, plug them in, and you get a numerical answer. So we'll leave it at that. That is an introduction to the definite integral.